Hello students, welcome back to here today's new video lecture. From today we are going to start here second chapter from the organic chemistry, that is alcohols, phenols and ethers. This chapter it is divided into three parts: alcohols, phenols and ethers. First of all, we will see alcohols, classification, definition of alcohols, then classification of alcohols, and then after that we will go to the phenols and ethers. Now first of all we will see here what are alcohols. The compounds in which hydroxyl group is attached to the sp3 hybridized carbon atom of saturated carbon chain are known as alcohol. Now before this we have already studied halogen derivatives. In halogen derivatives there is a X, that is halogen atom, as a functional group. Now difference is that here instead of this X, in alcohols hydroxyl group is there as a functional group, OH. It is a functional group. OH group means hydroxyl group. Hydroxyl group, it is a functional group present in alcohols. Now what are alcohols? The compounds in which this OH group is attached to the saturated sp3 hybridized carbon atom. Now see here, sp3 hybridized carbon atom means the carbon atom which is attached to, which has 4 single bonds like this, that is known as sp3 hybridized carbon atom. If carbon atom has a double bond and 2 single bond, that is sp2, and if a carbon atom has 3 bonds, triple bond and 1 single bond, that is known as sp. But here we have to attach this OH group to the sp3 hybridized carbon. Now this is sp3 hybridized carbon atom. The compounds in which this OH group is attached to sp3 hybridized carbon atom of saturated carbon chain, means such type of the single carbon atoms are there. There is no any double or triple bond. Such type of the compounds are known as alcohols. The compounds in which this OH group means hydroxyl group is attached to sp3 hybridized carbon atom of saturated carbon chain are known as alcohols. Before this we have completed that halogen derivatives. The definition of halogen derivatives is like this, same. Instead of this OH group we have taken there X. Halogen atom is attached to sp3 hybridized carbon atom. Here OH group is attached to sp3 hybridized carbon atom of saturated carbon chain are known as alcohols. Now for example, here examples are like this. CH, it is the first member of the alcohol series, that is CH3OH. It is methanol or methyl alcohol. Methanol is the IUPAC name. Methyl alcohol is the common name here. Or CH3CH2OH, it is ethanol. Now here it is alkyl group methyl, it is ethyl group. Alkyl groups are represented by a letter R, and this OH group, that is a functional group that remains constant in all these structures. Therefore they are represented by general formula ROH, where R is any alkyl group. Methyl, ethyl, I have taken here methyl and ethyl only. We can take here methyl, ethyl, N-propyl, isopropyl, N-butyl, C-butyl, N-butyl, like this. Therefore they are represented by general formula ROH. Or here see the first structure or any structure. There is 1 carbon atom and 4 hydrogen atom. It means that if we have considered Cn, then we have to consider this Cn H2n plus 2 and O. Cn H2n plus 2O is the general formula of an alcohols. Now this much part, this OH group that remains constant in all these structures, that constant part is nothing but the functional group of that structure. Therefore they contain functional group, that is hydroxyl group. OH group means hydroxyl group as a functional group. OH group is known as hydroxyl group. In this way we can define the alcohols. I will read it once again. The compounds in which hydroxyl group is directly attached to the sp3 hybridized carbon atom of saturated carbon chain are known as alcohols. They are represented by general formula ROH or CnH2n plus 2O. For example, methanol, ethanol, methyl alcohol, ethyl alcohol. It is regarding about the definition. Now classification. Here it is a classification. Now classification of alcohols, that is given in different ways. First of all, we will see on the basis of number of OH groups present in a particular structure. On that basis, alcohols are classified as follows. Similarly, similar to that of halogen derivatives of alcohols, monohalogen, dihalogen, trihalogen, polyhalogen, like that, on the basis of OH groups, alcohols are classified as monohydric alcohols, monohydric, then dihydric, trihydric alcohols. Monohydric alcohols means they contain only one OH group. They contain only one OH group in that structure, are known as monohydric alcohols. For example, CH3OH, C2H5OH, they contain only one OH group. Therefore, they are known as monohydric alcohols. Methyl alcohol, ethyl alcohol. This one, methyl alcohol, ethyl alcohol are the examples of monohydric alcohols as they contain only one OH group. Here now dihydrics, di means two. Dihydric alcohols, they contain two OH groups in their structure. For example, here I this like this, CH2OH, CH2OH, 1 and 2. Two OH groups are there, therefore it is known as dihydric alcohol. It is known as ethylene glycol. Ethylene glycol or 1,2-dihydroxyethane. Ethylene glycol, it contains two OH groups. Here now, similarly, if there are three OH groups are there, that is known as trihydric alcohols. Trihydric alcohols. Here like this, 1, 2, 3 carbon atoms are there, 3 OH groups. Here we have to attach here CH2, CH, CH2OH. It is an example of trihydric alcohol because it contains 3 OH groups. Now, or it is the name of this compound is, it is glycerol or glycerin, or it is propane 1,2,3 triol. Propane 1,2,3. It is propane 1,2,3 triol. It is ethane 1,2-diol. Glycerol, ethylene glycol is also known as ethane 1,2-diol. Ethane 1,2-diol. In this way, it is a classification on the basis of OH groups. Monohydric, they contain only one OH group. Dihydric alcohols, they contain two OH groups. And here, if three OH groups are present, they are known as trihydric alcohols. Now, again, alcohols on the basis of this, on the basis of position of OH group on carbon atom. There are different types of the carbon atoms: primary carbon atoms, secondary, tertiary, and quaternary carbon atoms. Whether that OH group is attached to primary, secondary, tertiary, or quaternary carbon atom, on that basis, alcohols are classified as primary alcohols, secondary alcohols, and tertiary alcohols. Similar to that of halogen derivatives. Halogen, it is attached to the primary carbon atom, are known as primary alkyl halides. Cl, that is halogen atom, is attached to secondary carbon atom, secondary alkyl halides. Halogen atom is attached to tertiary carbon atom, tertiary alkyl. Similarly, just we have to replace that halogen atom by OH group. If hydroxyl group is attached to here primary alcohols, if carbon atom OH group is attached to the primary carbon atom. Primary carbon atom is that carbon atom which is attached to another one carbon atom or 3 hydrogen atoms like this. It is CH3, CH2, OH. It is OH group is attached to this carbon atom, which is primary carbon atom. Methanol are the examples of primary alcohols. Again here, it is ethyl alcohol. The compounds in which hydroxyl group is attached to primary carbon atom are known as primary alcohols. Here, isobutyl alcohol CH3, CH3, CH2OH. It is again primary alcohol because this OH group is attached to this carbon atom. It is primary carbon atom. This carbon atom, it is tertiary carbon atom. We are not concerned with this tertiary carbon atom. It is primary. The OH group is attached to primary carbon atom. Therefore, it is an example of primary alcohol. Neopentyl alcohol is also an example of primary alcohol. Here, CH3, CH3, CH3. It is primary carbon atom. It is primary. It is quaternary carbon atom. But this OH group is not directly attached to this quaternary carbon atom. It is attached to primary carbon atom. Therefore, neopentyl alcohol is also an example of primary alcohol. In this way, primary alcohols, OH group is attached to primary carbon atoms. Then secondary alcohols. Secondary alcohols. Here now, the alcohols in which OH group is attached to the secondary carbon atom are known as secondary alcohols. Secondary carbon atom is that carbon atom which is attached to another 2 carbon atoms, minimum 2 carbon atoms. Here, therefore, it is CH3, CH3. It is sec propyl alcohol, or it is also known as isopropyl alcohol. It is an example of secondary alcohol. Sec propyl alcohol or OH group is attached to secondary carbon atom. It is secondary carbon atom because it is attached to another 2 carbon atoms. Okay. Here now, and then the third type is tertiary alcohols. Tertiary alcohols. 3 degree. Primary alcohols are denoted by 1 degree. Secondary alcohols are denoted by 2 degree. And tertiary alcohols, that is to be denoted by 3 degree. Tertiary alcohols, here now, OH group is attached to that carbon atom, that should be tertiary, 3 degree. 3 degree means it is attached to another 3 carbon atoms like this. It is attached to another 3. We have to balance the valency of the carbon atom by using these hydrogen atoms. CH3, 3C, CH3, C, OH. It is third. There are 4 carbon atoms, therefore it is butyl. But OH group is attached to the tertiary carbon, therefore third butyl. It is third butyl alcohol or 2-methyl propan 2-all. That is tertiary alcohol. Here, primary alcohols, secondary alcohols, tertiary alcohols, OH group is attached to primary carbon atom. In secondary alcohols, OH group is attached to secondary alcohol carbon atom. In tertiary alcohols, OH group is attached to tertiary carbon atom. It is the classification of alcohols on the basis of that attachment of that carbon atom, attachment of that hydroxyl group to the carbon atom. Here now another class. Again, alcohols are also classified as allylic alcohols, benzylic alcohols, and vinylic alcohols, as like to that of allylic halides, benzylic halides, vinylic halides. Definitions are also same. Just we have to replace that halogen atom with OH, means hydroxyl group. Now, allylic alcohols are those alcohols in which hydroxyl group, means OH group, is attached to sp3 hybridized carbon atom. sp3 hybridized carbon atom means it is attached to 3 single bonds like this, CH2, CH2, and here again attached to another carbon atom. OH group is attached to, it is sp3 carbon atom. Okay. OH group is attached to sp3 hybridized carbon atom, which is further bonded to doubly bonded carbon atom, or we can say sp2 hybridized carbon atom. It is sp2. OH group is attached, listen carefully. Yes, OH group is attached to sp3 hybridized carbon atom. sp3 hybridized carbon atom means that is attached to 4 single bonds like this 1, 2, 3, 4. And that sp3 hybridized carbon atom is attached to doubly bonded carbon atom or sp2 hybridized carbon atom. That type of the alcohols are known as allylic alcohols. Here in halogen derivative of alkenes we have taken here EX. Instead of this OH we have taken here EX. Halogen atom is attached to sp3 hybridized carbon atom which is attached to doubly bonded carbon atoms. Same definition. तीच डेफिनेशन आहे जशाला तशी फक्त OH ऐवजी एक्स घ्यायचं आहे. हायड्रॉक्सिल ग्रुप म्हणायचं आहे हॅलोजन ॲटमच्या ऐवजी. रिमेनिंग पार्ट दॅट इज द सेम अँड हिअर वी हॅव टू राईट द एक्झाम्पल लाईक दिस. OH group is here instead of that X. Here we are taking here ClBrI. Now allylic alcohols, here it is known as allyl alcohol or IUPAC name of this compound is 1, 2, 3. 3 carbon atom, therefore parent alkene is propane, prop. There is double bond between 2 and third carbon, therefore 2 in, and OH group is present at first carbon, therefore 1 all. Prop 2 in 1 all is the IUPAC name of this alcohol. Again, I have not taken the examples here of that. Allylic alcohols are further classified as primary, secondary, and tertiary alcohols also. Then we can see you can see the examples in our board's textbook also. Benzylic alcohols. Here now another type, second one is benzylic alcohol. See here now again, OH group is again attached to sp3 hybridized carbon atom. Again here OH group is attached to sp3 hybridized carbon atom as like to that of allylic alcohols. But what is the difference? But this carbon atom in allylic alcohols, that carbon atom is attached to doubly bonded carbon atom. But here this carbon atom, it is attached to the carbon atom of benzene ring. Here that is the difference. Benzylic alcohols. OH group is attached to sp3 hybridized carbon atom which is attached to the carbon atom of aromatic nucleus, or we can say benzene ring structure. And the name of this alcohol is benzyl alcohol. Benzyl alcohol, or it is also known as it is methanol, and it is phenyl group. It is also known as phenyl methanol. IUPAC name is phenyl methanol or benzyl alcohol. Now another, finally, vinylic alcohols. Vinylic alcohols, see here, OH group is attached to. Now it is vinylic alcohols are different from that allylic and benzylic alcohols. In allylic alcohols, OH group is directly bonded to the sp3 hybridized carbon atom. But here in vinylic alcohols, that OH group is bonded to sp2 hybridized carbon atom. That you have to remember. It is attached to sp2 hybridized. Why it is sp2 hybridized carbon atom? Because it is attached to these two. Both are sp2 hybridized carbon atom. Because carbon atom having 2 single bonds and 1 double bond, that is known as sp2. All single bonds sp3. A triple bond and single bond sp3. It is this carbon atom, it has double bond and 2 single bonds. Therefore it is known as sp2 hybridized carbon atom. And therefore we can define like this. We can define the vinylic alcohols like this: alcohols in which OH group is attached to sp2 hybridized carbon atom, directly attached to sp2 hybridized carbon atom, are known as vinylic alcohols. And the name of this alcohol is vinyl alcohol, that is as like to that of vinyl halide, vinyl alcohol, or it is also known as double bond is, therefore it is ethene, ETHEN, and alcohols we have to use the suffix OL for alcohols, therefore ethanol. Ethanol is the IUPAC name and vinyl alcohol is the common name of this vinylic alcohols. With this we have completed the different types of the alcohols classification. Today we stop here. In the next lecture we will see the nomenclature of alcohols. Thank you.